Hi all, welcome to Relational Algebra Part 2, and in this video we are going to learn about a relational operator called the join operator. So it is basically a derived operator. It is represented by something like this, and it is derived from the basic operator like cross product, selection, okay, and projection. So these are the basic operator from which it is derived, right? And in this video, we are going to learn about different types of join. Okay. So the very first type of join is natural join, right? So what happens in natural join? Natural join basically is represented by this symbol, and let's see first all the types of join. So first is natural join. Second is conditional join, that is also known as predicate join, because here for the natural join we are applying certain condition. So on natural join we are applying certain condition like C. Okay, so this is called conditional join. And the third one is outer join, which is further being categorized into three parts. Okay, so all these three are, the very first is left outer join, uh, uh, left outer join, which is represented by this symbol from the left, and it can be either natural join or it can be conditional join as well. Okay, so this way. Okay, similarly we have right outer join. So right outer join would be represented by this symbol, or it could be a conditional join represented by this. Okay, and the third one is full outer join. So it is a combination of left outer join and the outer join. So it is full outer join, full outer join, and this can be represented as this, this, or it could be a predicate condition like this. Okay, so these are the different kind of outer join. Okay, so we will be seeing each of this join one by one. So let's know about what is called the natural join. The very first is the natural join, right? So natural join represented by this. Now if we have two relations R and S, and if we are taking the natural join, it means how we are constructing this natural join. So we are taking the columns of R and S, and we are doing the cross multiplication of R and S in this, and then we are selecting based on the common attribute where r dot c equal to s dot c. Okay, so this is we are selecting, and here we are having r, a, b, c, and d. Okay, so basically already we have constructed, but let's generalize this. So we are selecting the distinct attributes from r and s. Okay, and here we are selecting, applying a condition on r cross s, and this condition is based on the equality between common attributes of r and s, equality of between common attributes, common attributes of r and s, right? Okay, so in order to understand it, so first, for any natural join, R natural join with S, first we are doing the cross product of R and S. Okay, so first we are doing the cross product. Then on this cross product, we are applying condition based on the equality between common attributes of R and S, equality between common attributes of RNS. Okay. So first we are doing a cross product, then we are performing the equality between common attributes of RNS, and then we are projecting the distinct attribute of RNS. We are projecting the distinct attributes of RNS. Okay, so this is all about the natural join process. So basically we already have the relation. I will just write it here. The RNS relation was already there, so let's see. We'll do that. So this is R, and this R consists of A, B, C attribute, and it has value like 245, 347, 245, 347, and 735. Similarly, we have a table S, and it has attribute C and D, and the values of the attribute are 5, 6, 4, and 5. So first we are doing the cross product. Okay, so first we are doing cross product of R and S. So that will be equal to A, B, C, 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 D. Okay, so since this C corresponds to R, this C corresponds to S. So it will be something like 2, 4, 5, 5, 6, 2, 4, 5, 2, 4, 5, 4, 5, then 3, 4, 7, 5, 6, 3, 4, 7, 4, 5, and correspondingly we will be having 7, 3, 5, 5, 6, and then 7, 3, 5, 4, 5. Now we are applying a predicate condition that are the common attribute between these two, that is the C attribute, has to be equal. That is R dot C equal to S dot C. Okay, so after applying this attribute, now we are left with this relation A, B, C, and D. So we are just taking this common. So if 5 5 is common here, then here it is 5 5 common. Okay, and I think we have just this one common, right? So yep, so this is only common here. So we are just taking the common attribute where R dot C is equal to S dot C. So this will be segregated out, and this will be segregated out. So it will be something like 2, 4, 5, 6, and it will be 7, 7, 3, 5, and 6. Okay, so this one. So only two attributes got segregated based on the equal condition, and then we are projecting all the attributes like A, B, C, D. So this is the result. So basically, we are doing it in three steps. First, we are doing cross multiplication. Second, we are applying the condition based on the common attributes. And then we are projecting it into a table with all the attributes present in that. And all the attributes has to be distinct. Okay. So here, after applying condition, it will be something like A, B, C, C, D. Okay. So it will be CC, I mean 2, 4, 5, 5, 6, 7, 3, 5, 5, 6. But after applying this projection condition, okay, so after applying this projection condition, that is in the third step, we will be having like this table A, B, C, D, because here we are applying distinct attribute condition. So 2, 4, 5, 6, and 7, 3, 5, 6. Okay, so this is all about natural join. We are segregating things based upon the equality between common attributes of RNS. Okay, so yep, this is one thing. And yeah, we can write something like if we have a relation R, and R consists of attributes A, B, C, and S contributes consists of attribute B, C, D. So if we have the common attributes here B and C both, so we can write something like if we are taking their natural join, so the natural join of R and S will be having this attributes like uh, A, B, C, D, and here we will be applying the condition like R dot B is equal to S dot B, and R dot C is equal to S dot C, and then we are doing the cross product of R and S, right, like this. Okay, so yep, this is all about if we don't have the common attribute. So if we don't have common attributes such as if R is there and R has attribute AB and S as attribute CD, and you see there is no common attribute, then simply the natural join will be of R and S would be including A, B, C, D and R cross S, right? So natural join is equal to the cross product of two relation when we have no common attribute, no common attribute. But whenever there is a common attribute, then we have to uh, apply the predicate condition over the common attribute. We have to check the equality between common attribute of R and S. Okay, yeah, so this is all about natural join. Next we are going to see um, we have a conditional join, right? So now we are going to see about the conditional join. So yep, this is the second part, conditional join, and it is represented by this symbol. Okay, here is our condition. Now how to apply condition? So we have R conditional join with S, then we are applying some condition like over R cross S we are applying certain conditions such as C. Okay, so something like if we have R natural join with S, and we are applying here the condition like R dot C has to be greater than S dot C. Now this is a different case from natural join. So it means that over R cross S we are applying a condition where R dot C has to be greater than S dot C. So if you again look back to the table, what we are getting from here is that if we have a relation R, and that consists of let's say mm, R consists of A, B, C, and it is 2, 4, 5, and 3, 4, 7, and 7, 3, 5, and then we have a S relation, and that consists of C and D, that is 5 6 and 4 5. And if we are doing the cross product first, so first we are doing cross product. If we have to obtain R conditional join with S such that the condition is R dot C is greater than S dot C, right? I think it was the condition. Now, first we will be applying cross product. So the cross product will yield into A, B, C, C, D, and let's go shorter, 2, 4, 5, 5, 6, 2, 4, 5, 4, 5, 3, 3, 4, 7, 5, 6, 3, 4, 7, 4, 5. Then we have 7, 3, 5, 5, 6, and lastly we have 7 3 5 4 5. Okay, so this is R cross S, and after that we are applying this predicate condition says that R dot C is greater than S dot C. So we are selecting attributes where R dot C, this is RC and this is SC, where R dot C is greater than S dot C. So which is the condition? Yeah, this got trapped here. Okay, this got trapped here, right? And this got trapped here. So altogether, yeah, this one also. So altogether we have four attribute here. So we will be having A, B, C, C, D, and here we will be having 2, 4, 5, 4, 5. Then we are having 3, 4, 7, 5, 6, and 3, 4, 7, 4, 5, and then lastly we have 7, 3, 5, 4, 5. Now see here, we are not joining these based on the common condition, I mean the common attribute, because here we are making comparison between these common attribute only. So definitely in the final relation, all these four tuples will be there, right? You can't write one C for that because you have two different values for the C, right? So you can't write one single. So this will be the final set of result. So if we want to write this in terms like um, r join s, so with condition r dot c greater than s dot c, so it will be something like applying condition r dot c greater than s dot c over the cross product of r and s. Okay, this is like this. Similarly, we can write something like r conditional join with s such that r dot a greater than equal to 5, then uh, including and s dot d greater than equal to 5, right? And r dot b is greater than not equal to r dot b greater than s dot c. So something like this, all these condition can be applied. So it will be simply equal to applying predicate condition such that r dot a greater than equal to 5 and s dot d greater than equal to 5 and r dot b greater than s dot c, and this is applied over the cross product of r and s. Okay, so yeah, so if we are applying this condition, so if r dot a greater than equal to 5, so we have two condition for that, right? This one. Then we need to see whether s dot d is greater than equal to 5. Yes, this also satisfied. And lastly, we have to see that r dot b greater than s dot c. So r dot b is greater than s dot c. So this is not happening. Okay, so one of the condition fails in this and situation. So we have an empty table. Okay, this is empty. So all these condition has to be satisfied for that, right? That's all for conditional join. Now the most important part is outer join that we are going to see next. So third is outer join. Now outer join, as I have already told, it is of three types. So first of all, we'll see the left outer join. Okay, so left outer join. So what happens in left outer join, we represent it by this. So please note that in the left hand side, this is open. So if we are doing R and S, so it will be something like this. Now this is its mouth has been opened towards R end. Okay, so it means that we are doing a natural join of R and S, and and it also includes records of R that failed the join condition. Okay, that failed the join condition. Okay, so we already have our if we are writing like this, our left outer join with s, then we are some doing something like this. We are having our natural join with s, and we are including the records of r failed the joint condition, failed join condition. Okay, so if you see, we have already done the natural join of r and s, and that does includes this part 2456 and 7356. Okay, so 2456 and 7356, so it will include a b c d 2456, and it also includes 7356. Okay, So 7356. So these are the product of natural join. Now what are the other condition of R which failed this join condition? So if you look at R, so 2456 has been matched with this, and 7356 has been matched with this, but this failed the joint condition. So 347 failed the joint condition. So we will be including it here. 347. Now we don't have D for that, so we can keep it as null. So this way it is a result of left outer join. Now you can understand what does a right outer join means. So it is very much clear from this part only. So if we talk about second is let's talk about the right outer join. So this is right outer join, and for this right outer join, if we are doing right outer join of R and S, so the mouth will be open towards S, and it will be including R conditional join with S, and records of S that are not present in R, that are not present in R. Okay, so R right outer join with S means record R this one. Okay, please ignore this lining part. Actually I have been writing in the opposite direction, let me correct this. Okay, so it will be something like R and S, and the mouth will be open towards S. Okay, so it will include the join of R and S along with those records of S that are not in the join condition. Okay, that failed the join. So it will include 2456 7345. Okay, so it will be including A, B, C, D, and it will be including 2456, and it also includes 7356. It also includes 7356, and it includes the records of S that failed the join condition. So it will include the records of S that is failing the join condition. So this is the only record of S that failed the join condition. Okay, because this has been paired with this. So 4 and 5. So in C and D we will write 4 and 5, and here it will be null, and here also it will be null. So this is the result of right outer join. Okay, now with this it got in different direction, but okay, let's see, the third part is full outer join. So full outer join is nothing but the combination of left outer join and the right outer join. So full outer join, and it is nothing but we represent it by this: both side mouth is opened. Okay, and it is nothing but a combination of left outer join and union of right outer join. Okay, anywhere I put that intersection mark, please ignore. Okay, this shouldn't be intersection, it is union. See, we are making union of these two, so please ignore this part. It okay. So yep, this is regular join, union, record of R that failed the joint condition, and this is our right outer join will be our regular join, union, record of S that failed the joint condition. Okay, and this is of course the combination of these two. So this will includes the records of us the common attributes. So A, B, C, and D, and it will include first 2456 7356, and then it will include records from outer join, this part. So here it will include 347 null, and from this part, so it will be null null, 4 and 5. We already have calculated this above. Okay, so this one, and from this one. Okay, so yep, so this is about the full outer join and all. So yeah, you can write it into something like, if you have to write the right outer left outer join, you can write it in this form also. So it will be R natural join with S, and then we are doing union, and then we are doing records of R which are not present, which did not participated in join, and we are multiplying it with the so from R we are subtracting those records which are present in R natural join with S. So from R, we are subtracting those records which are present in the natural join, and then we are doing it cross product with null, 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 whatever be the number of attribute that are present in S. Okay, so this way, simply in a similar way we can write for the right outer join as well. So it is something like a natural join of R and S, and then we are doing union, and we are also adding the records of S which failed the join condition. Okay, so we which failed the join condition of R join S, R join S, and here to append null null we should be appending null null before, like here we need to append the number of null for the number of attribute in R which are not in S, and we are multiplying it with this. Okay, so this is one way of representing the right and left outer join. Okay, now we will be seeing about the number of attributes being present in uh, about the how many minimum and maximum tuples we can operate can be present from these operation. So I think I should be closing the video here. We'll see about that in the next video. So I think this video clearly explains about the different types of join, and that's all for this part. We'll see about remaining thing in the next video. If you do have any comments or questions, please do comment in the comment section, and I'll be happy to help. Thank you very much.